Welcome back. This video is going to be over units and measurement and base units in the metric system. So there's two main measurement systems, what we use in the US and what the rest of the world uses. And it's referred to as the International System of Measurement, or you will see it abbreviated SI, which is basically an abbreviation. I believe it's French, and it's like Système International. I do not speak French, but that is where that comes from. And if you see the SI units, that is referring to this International System Measurement. And this is just revised from the metric system. Now, just keep in mind, only 3 countries in the world still do not use the metric system, and the US is still proudly one of them. The other 2 being Myanmar and Liberia. So there's not many countries that will use the system of measurements that we are accustomed to. So that's why it can be confusing when we travel abroad. When we see temperatures no longer in Fahrenheit, we see it in Celsius, we see distances measured in kilometers and meters, and see things listed in weights in grams and kilograms instead of pounds. But the metric system is fairly straightforward. Based on multiples of 10, it's pretty much used, even in this country, by most scientists and engineers. And what's nice about it is that it uses the same prefixes with different base units. So the prefixes just make the base unit smaller or larger. And here's a table with various units or prefixes ranging from mega, kilo, centi, milli, micro, and nano, and all of them, this is not all of the prefixes. This is just a sampling of them. And here's some of their symbols and the numerical value and the equivalent power of 10. So for example, mega, usually you see as a prefix, going to be a capital M in front of whatever the base unit happens to be. Kilo is a lowercase k, centi, milli, micro, and nano. And roughly these two this would be considered the base, whatever the base unit is in this row right here. Kilo, mega, much bigger than the base unit. All of these down here, centi through nano, much smaller than the base unit. Okay, for this class, there are 3 metric prefixes that you will be required to memorize what they represent mathematically. And those are kilo, centi, and milli. Everything else, when needed, will be provided to you for the conversions. But you need to know centi, milli, and kilo. So let's talk about base units. For time, base unit is the second. Okay, no big surprise there. So whenever we're timing something if we have to time anything, we're going to typically measure that in seconds. The base unit for length is the meter. However, we will commonly use the centimeter or possibly the millimeter, because the meter is kind of big. And most of the stuff we're going to be doing in our class, if we're doing a lab that involves lengths, they're going to be somewhat smaller. They're going to be centimeter type of quantities or millimeter type of quantities. Excuse me, we've got chemistry cat coming through. Bye-bye, kitty. I know you want attention, but the students want to learn. Mass, the base unit, is the gram. And we will use grams. Possibly, no, we will not use kilogram. Remember, mass is the amount of matter an object contains. And a common misconception that people have is mass same thing as weight, but no, they are not the same. Weight and mass are different. Weight is a measure of the pulling force of gravity on an object. Right? When you step onto a scale, a bathroom scale, or if you're measuring, you've got a kitchen scale and you're measuring quantities of something, you're measuring its weight, not its mass. However, if the location doesn't change, then the mass and the weight can be used interchangeably. But hopefully you all can understand that if you step on a bathroom scale in your bathroom, you're going to see your weight. Now, if you are all of a sudden transported to the moon with your bathroom scale, hopefully you can understand that it is not going to weigh the same, or it is not going to read the same. It's not going to show that you have the same weight. And that's because the acceleration due to gravity, your chemistry cat has to go. It can change due to differences in the local acceleration due to gravity. All right. Temperature. We will use Celsius. And this temperature is defined as a measure of the average kinetic energy of particles of matter. Right. Celsius scale. See, you should be familiar with it. You should have heard of it. Just has a little degrees symbol and then C. Obviously, we are used to Fahrenheit, which you would have a small degree sign and a capital F. Freezing point of water is 0 Celsius. Right, in what you would be used to probably is the freezing point of water is 32 Fahrenheit. And that's, freezing point of water is 0 Celsius, not just degrees C. But that's equivalent to 32 Fahrenheit. We're not going to be really converting from Celsius to Fahrenheit or vice versa, but I'm just using these values for a comparison or reference standpoint. And the boiling point of water on the Celsius scale is 100, which corresponds to 212 Fahrenheit. Obviously, you can see these numbers are much easier to remember than these numbers. Everything in the metric system is typically a lot easier to understand. Absolute zero. This is defined as the temperature where there is no motion of particles of matter. That's when all particle motion ceases at basically the atomic level. There's no known place in the universe where absolute zero exists, even in the vast cold emptiness of space. Temperature is typically like 4 Kelvin. And I get ahead of myself because we haven't talked about Kelvin. But Kelvin is another type of temperature scale, one that is one-sided versus two-sided. You cannot have, 0 Kelvin is the absolute lowest temperature whatsoever. That is defined as when all particle motion stops. And we will be using Kelvin when we get into the gases unit later in the year. But one thing to keep in mind here is the conversion between Kelvin and Celsius, where to convert to Kelvin, you take whatever your Celsius temperature is and add 273.15 to it. You don't have to memorize this formula. It is on the back of your periodic table. Okay, obviously, hopefully you can understand that if you're trying to convert from Kelvin to Celsius, well, your Kelvin value would be plugged in here. You're solving for Celsius, and so you're going to end up just subtracting it. Okay? And one other thing, keep in mind, on Celsius, it's degrees Celsius. That's how it's, you would say it's 30 degrees Celsius outside. You don't do the same thing for Kelvin. There's no degrees Kelvin or a degree symbol there. It's missing. There's nothing there. And so if you were to say, hey, what's the temperature outside? Well, if it's 30 degrees Celsius, that would correspond to roughly 303 Kelvin. You wouldn't say 303 degrees Kelvin, you just say 303 Kelvin. Okay, so let's do a couple examples here. We want to convert 25.6 Celsius to Kelvin, right? We're just going to use the formula, the conversion formula as is that you see on your periodic table. plug in our value, 25.6 Celsius plus this 273.15. Put it into our calculator, which I will not show, but it will be 298.8 Kelvin. Very important. Get the value and the unit. And we will discuss later in this unit why there's a single decimal place here. When this has 1 decimal place, this has 2. We will get into that later. But key thing is whenever you put it right, get a calculation, always have a value and a unit. It's going to be very important because you'll get points for both things, for both the correct unit and the correct answer with the correct numbers there. Now if we're looking at this one, convert 202 Kelvin to Celsius. Well, remember this is our original formula. We just rearrange it to get Celsius by itself and plug in our values, 202 Kelvin minus 273.15. So when we do that, we are going to end up with around negative 71 degrees Celsius. Okay? Now, going on to the next piece. Calculate volume. The base volume, the base unit for volume is liters. Right? We will typically, in the lab, we are not going to use the quantities that are going to be liters because that is just a large amount of something. We are going to typically record volume in milliliters. Keep in mind, one type of unit of volume that you are used to is the gallon. Right? You get a gallon of milk carton or a gallon of something. 1 gallon is roughly 3.78 liters. Right? So a liter is a little, about the size of a quart, if you're familiar with that. And that's typically not going to be the size of quantities that we are going to be using in any type of lab we do. So we will typically use the milliliter. Or we also will use cubic centimeter, because that is also a unit of volume. Now, volume is defined as the amount of space that is occupied by matter. And there's multiple ways that you can determine volume, depending on what you're trying to determine the volume of. For a simple rectangular solid, hopefully mathematics has taught you the formula for volume is going to be the length of something times the width times the height. And, for example, if all of our measurements were in centimeters, right, centimeters times centimeters times centimeters, well, the unit are going to be cubic centimeters. And that is what we would, that's where the cubic centimeters come from. Typically, cubic centimeters are going to be, or sometimes referred to like in healthcare or in other things, sometimes referred to as cc's, like cubic centimeters. Instead of cm cubed, they'll just refer to these as cc's for cubic centimeters. 1 cubic centimeter is defined, it's the same as 1 milliliter. Right, so this is a conversion factor. 1 cubic centimeter is equal to 1 milliliter. Now, if we're talking about liquids, typically, if you want to measure a liquid's volume, you're going to use a piece of equipment called a graduated cylinder. You will get some experience using and measuring these things, measuring volumes of liquids in the lab. And all of ours that at the lab stations are labeled in milliliters. Now keep in mind, when you're reading volume, you want to, first of all, be reading the volume of the liquid at eye level. And what this often means a lot of people, what I see a lot of students doing when they're trying to read volume of a liquid in a graduate cylinder, this is what this kind of represents, graduate cylinder, is that they will raise the graduate cylinder up to their eye level. And that's kind of an inaccurate way of doing it. What you want to do when you're reading the volume of a liquid in a graduate cylinder is place the graduate cylinder on the counter or the lab station bench or whatever, and bring your eyes down to its level so that it is sitting on something that is level, and so you're not going to introduce some type of measurement error. Just like hopefully when you are measuring liquids at home, let's say you're cooking or baking something and you're trying to measure how much milk or how much water you need to add. You've got a clear glass measuring cup, and when you pour the liquid into the measuring cup, if you want to get one, trying to add a half a cup or 3/4 a cup or whatever, typically you're probably not going to raise the measuring cup up to eye level to read what the volume is, because you could be tilting the cup backwards or forwards and it's not going to be very precise. Okay, kind of do the same thing in the lab. Now, one thing you notice, there's two things here. The surface of the liquid, come on, welcome back. Just had some minor technical difficulties, which I will have to edit these videos together because Mr. Chemistry Cat decided to step on keyboard and close down the recording software, which will happen when you're trying to record a chemistry notes video around a Maine Coon kitty. Anyway, we were here want to read the liquids at eye level on a nice level surface. And you'll notice these two, most liquids will have something, if you look at a cross section, it will look something either like this, and this is referred to as a meniscus. No, we're not doing this again, kitty. And you want to read the volume at what is referred to as the bottom of the meniscus. So right here would be considered the bottom of the meniscus, right? Where it reaches the high up, it would be the top. So you would read this level here for the volume. Mercury is different. It has a meniscus where it has an opposite shape, where it's lower at the sides and higher in the middle. Mercury, you would read it at the top. Okay. And lastly, to determine the volume of an irregularly shaped solid, you're going to want to use water displacement. And what you're looking for there is you place the object in some water in something that can accurately measure volume of liquid. Place it in water and see what happens to the volume of the water. To see how much it changed by, because when you submerge the object in the water, obviously the volume of the water is going to, the liquid's going to increase, and whatever that was is basically the volume of your irregularly shaped object. Okay, so that can be very useful for something that doesn't have a nice regular shape. All right, thanks for watching, and I'll see you on the next one.